Well, good day, everyone. This is Dr. Shinto from the Faculty of Engineering and Built Environment, Master University. I hope every one of you have a great time. Today, I am delighted to have Associate Professor Dr. Abdurrahim Sadiq Bacha. Associate Prof. Dr. Sadiq obtained his PhD from Multimedia University in Malaysia. He received his Master of Engineering in Power Electronics and Drives Engineering from Bharathidasan University in India in 1998 and Bachelor of Engineering degree in Electronics and Communication Engineering from Madurai Kamaraj University in India in 1989. He's a chartered engineer from UK Engineering Council, and he's a graduate member in the Board of Engineering Malaysia (BEM), and also he's a member of various professional bodies such as IET, IEEE, ISTE, and so on. He has over 30 years of teaching experiences at several tertiary institutions in India and Malaysia, and he's also a certified trainer and can provide training on outcome-based education, artificial intelligence, and machine learning. So he has also held several key administrative positions at various institutions, which demonstrated his leadership attributes. He has served as a keynote speaker in various seminars and conferences, and also he appointed as a reviewer for peer-reviewed journals. Moreover, last but not least, he was an organizing chairman in various international conferences. So, Associate Professor Dr. Sadiq, I am so happy and glad having you today. I will pass the platform to you. If you have a greeting and you want to have your presentation, we are all here. Thank you so much, Prof.
Thank you, Dr. Singh, for your nice introduction. Assalamu alaikum and good evening to everyone. I'm Dr. Sadiq, the Associate Professor in Department of Electrical and Electronic Engineering, Faculty of Engineering and Built Environment, Masa University, Malaysia. Today, webinar session is about the concepts of artificial intelligence and its use cases. We are aware that nowadays the technology trends move towards artificial intelligence. Artificial intelligence peeps into all fields from education, business, agriculture, medicine, environment, etc., etc. So with this, today I'm going to deliver my session on these concepts of artificial intelligence and its use cases. As I mentioned earlier, we have many problems facing today, like curing diseases, addressing climate changes, and industrial aspects of, problems. All becomes easier because of the new technology, artificial intelligence. On top of that, great medical revolutions happens nowadays due to AI for the efficient drug discovery, diagnosis, and surgery. Moreover, e-commerce, education, and agriculture, and Industry 4.0, all these sectors are occupied by artificial intelligence. First, let me give a definition. What is artificial intelligence? What is AI? People always talk about AI. So AI refers to the simulation of human intelligence, like learning, reasoning, and perception. These are all the intelligence of a human being. It can be programmed in a machine. The machine can think like humans and mimic like their actions. So that we can call it as a broad area. We can call it as artificial intelligence. But in artificial intelligence, we have two subdomains: machine learning and deep learning. What is machine learning? It is a subset of AI, which refers to the concept that computer programs can automatically learn from and adapt to new data without human intervention. Whereas the deep learning, what is the difference between machine learning and deep learning? Deep learning techniques enables this automatic learning through the absorption of huge data. These data are unstructured data, for example, text, image, video. So this is the difference between machine learning and deep learning. Machine learning handle data which is lesser, but deep learning huge data. The data can be uh, text, image, and video. So the application areas: business, agriculture, medical industry, environment. These are all the application areas. So now I'm going to give what is the concept behind machine learning and what is the concept behind deep learning and its use cases. This is the today's core topic of this webinar. Machine learning, basically, it is a. I told you in the process of machine learning, actually learning and improving the data for inference, various inferences. So learning is the process. Actually, the machine we have to train the machine to learn the data, and based on the data, the machine can perform and give its inference. So this is the machine learning basics. So in the process, first we have to give the input data. That from the data, the features are extracted, and we have to create a model to try based on the data to train the model and test the model. Once the testing is done, so we have to identify the model is working properly, what the accuracy is proper. Then based on the inference, we have to implement this model in the real-time life. So here the main process is training our AI model and testing our AI model and evaluate the AI model. So in order to do this one, data is the main thing, because here the input is the data. From the data we have to extract the features. That feature is the input for our model, machine model. Okay, there are three types of machine learning process. One is supervised learning. In this supervised learning, the model learned from labeled data, because we have to put the label of the data. For instance, here we see we have to classify pizza and donut. So our input is the pizza and donut, but we have to label pizza and label the different images of donut. So from this, the data can extract the features and it classifies whether it is a donut or pizza. So there are two models we can create. One is a regression module, another one is a classification module in machine learning. So this is an example of this pizza identification of pizza and donut is a example of a classification model of machine learning. So and then in unsupervised learning, the model means the machine learning AI model learns the inference from the unlabeled data. And then the third one here, you see in the second one example from the diagram, we can see the donut is not labeled and pizza also it's not labeled, but the model using the unsupervised learning, it can identify whether it is a pizza or donut. And the third one, one pizza is labeled, one donut is labeled, but from this data, the trial and method, it can identify it is a donut or classify it is a donut or pizza. So this is the example. So this example can be any images like your houses, different types of houses, different types of pictures, cat, different type of animals it can classify. So in this modeling, what is the core of this model is a algorithm, because this we have to use the algorithm, and based on the data we have to train the model, and from the trained model we have to test it, then it will give the results, your inference. So what are the different types of algorithms used in supervised learning? Support vector machine and decision tree. These are all the two types of algorithms used in supervised learning. Whereas in unsupervised learning, K-mean and a priori is the algorithm, because algorithm plays a major role in this machine learning model. So once the model is created, this model will give a inference for the classification problem. So the other problem is a regression problem. Sometimes we need to calculate the house price based on the areas. So in that, this is an example of regression model. So we need to go for develop a regression model using machine learning algorithm. So the algorithm is random forest or linear regression method. So these are the two methods used for when you design a machine learning model for a regression type of problems. So now we what are the how to develop the algorithm actually in machine learning model in AI, the mathematics is a key component. So mathematical, if the vector probability, these are all the metrics, these are all the mathematics used in machine learning and deep learning model. So in this model, for a regression problem, this is the equation. Based on the equation, here y equals to w naught plus w1 x1. So these are the different features. X1, x2, x3 are different features. For example, if you are using a predicting a house size is x1. How many bedrooms? So these are each x1, x2, x3 is a variable, and w1, not w1, w2, w3 are weights. So this is the mathematical function. Based on the mathematical function, we have to develop our algorithm. So this is an example of a regression type of equations, and the support vector machine is the mod algorithm used for this type of applications. So this is one of the use cases. What is the use cases? Predicting house price, transport arrival time. These are the some use cases. Use cases means applications. Then the second type of machine learning model is a classification model. So in this, it will predict the class labels, categories of the data. What type of data? For instance, if you are predicting a gender, or if you are predicting a donut, previously the donut and pizza classifications. So here, this is the objective functions. Using these objective functions, we have to develop the model with the SVM algorithm. This is the objective function for the support vector machine algorithm, because as I mentioned earlier, support vector machine is a supervised machine learning algorithm. In this algorithm, we are using the objective function like this. So it is a mathematical term. Here we are having a loss function and a regularization. In the subsequent slides, I will explain what are the importance of these loss functions and first functions. So in machine learning, we have to get a structured description or model from the analysis, and then use to predict an unknown future data. Unknown future data means the price of prediction of the price of the house prices and all for the next 5 years. So this is machine learning use cases. So as I mentioned earlier, decision tree, support vector machine, k-means clustering are the algorithms for this machine learning model. Okay, once you develop a model using the support vector machine, let your data is a house price. So what happened next? Next, you need to evaluate your model, because whether model is accurate or not. So in that, there is a evaluation matrix. It is a classifier for the performance of using test sets. So at the end of the evaluation matrix, we have this. For example, if a lady is because this is an actual class and the predicted class. If you arrive the correct conclusion, then it is true positive. For example, if a lady is pregnant, if she is found pregnant, it is true positive. But if a lady is pregnant, but the model predict it is you are not pregnant, means it is false negative. The statement is false negative. Okay. If a male, it identify the male is a pregnant, the model identify a male as a pregnant person, means it is a false positive case. If true negative, means again it is a correct conclusions. So based on this confusion matrix, we have to measure the accuracy of the model, because why? Once you train the model, we need to test the model before we implement. because what are the metrics we are using for the performance of the model? Accuracy, the formula is true positive plus true negative over positive plus negative cases. This is the formula, and we need to predict the error, precision, specificity, FP rate. These are all the metrics to evaluate the performance of the your model, whether it is a a regression model or it is a whatever the model, classification model. Based on this, the accuracy tell us whether the model is being trained correctly or how it performs generally. For instance, if your accuracy is not correct, you have to configure the model again and train the model again till you reach the accuracy, good accuracy. So until the test point, if you reach the satisfied test point, then you cannot implement your model, because this model will not go for implementation. So next one, so far we discussed about the machine learning concepts. So first one is modeling. Second one, modeling from the data. Data we can use structured data. Structured data or unstructured data. So basically labeled or unlabeled data. So once you give the data and train your model, so the model consists of algorithms, which is a part of the algorithm. You have the objective functions. So once after you develop your model, once you train your model, you need to train the model. How to train the model? With the help of the data. You have to give input to the data and train the model so that the model can learn the pizza, characteristics of pizza and characteristics of donut. After that, you need to test. You have some data. For example, if you have 100% data, 80% data you use it for training the model, and remaining 20% data you use it for testing the model. So once you test the model, you have to evaluate based on the evaluation metrics. If it is more accurate and more precision, then your model is a perfect model, and you have to go for the implementation. For example, if your accuracy and precision is not satisfied, you have to again train the model with the data till you reach the accuracy. So all these models, machine learning models, is a AI model. We can call it as AI model. It's nothing but a program, intelligent program. It can automatically learn and adapt new and predict the future data. This is for machine learning. So in machine, what is the difference between machine learning and deep learning? Because in the beginning of my talk, I mentioned two types of subsets. One is machine learning and deep learning. It is these two sets comes under artificial intelligence. In machine learning, the features means the characteristics are extracted manually, whereas in deep learning, the automatic feature learning process. So this is and moreover, deep learning, if the data is a huge amount of data, we have to go for deep learning model. For instance, natural language processing, computer vision type of application. So based on the application, the programmer can identify whether we have to develop a machine learning model or deep learning model. So for example, some examples, these are some examples. Your Netflix, Google Translation, chatbots, spam and wanted email. These are all the examples, your day-to-day examples. They use machine learning use cases. Okay, so I hope that you all understand machine learning. I summarize machine learning. Machine learning is a subset of AI, which refers to the concept that programs can automatically learn from and adapt to new data without being assisted by humans. Basically, the numerical data, and the various phases of basics is a data feature, and by human intervention, as well as modeling, train the model, test the model, evaluate the model. So whereas your data is more huge data nowadays, data science become more popular because every day we are handling huge amount of data, images. It is in the form of images, sounds, text. So we need an automatic feature extraction. And why nowadays deep learning is become more popular? Because deep learning in the beginning, in the past, our computer processor is limited. Okay, now due to the advancement in the computer processor and graphical processor, all the development leads move towards deep learning, and data handling capacity is with our current technology, electronics technology, the data handling capacity is more, so that we go for deep learning nowadays. So, and then applications are huge now. Now complex applications are there, so that's why we go for a deep learning. So deep learning actually, the definition is it is algorithm of structured neural networks which handle a huge amount of data. So here in machine learning, we are using machine learning algorithm like a support vector machine, decision tree and all. But whereas when you go for deep learning, the neural networks come into place. So later I'll explain what is neural networks applied in deep learning, because in today most of the applications are based on deep learning approach. For example, I'll introduce first the use cases, the applications. History is made. Google's AlphaGo wins the match against the champion Lee Sedol. You know, Lee Sedol is the champion in chess. So, but the Google's AlphaGo wins the champion. So, how the AlphaGo uses the deep learning model algorithm, so that it is used in games. Deep learning AI used in games. This is a typical example. And moreover, human voice and sounds all being extracted from these deep learning algorithms. And nowadays, we can make images like become our images like older, younger. All these use deep learning approach. And another example is medical field, a tremendous application of deep learning approach in medical field for the identification of diseases. For example, cancer patients, breast cancer is diagnosed by, pathologists, and AI. But the result shows that whether the results are more accurate than the pathologist compared to the deep learning AI model. AI model outperforms for identification of cancer. So it is this application, tremendous application in medical industry. In future, now research are going on using the AI technology. We have to perform delicate, complex surgeries. So now people are moving towards applying the artificial intelligence in medical industry as well as space exploration. So these are the use cases for deep learning. So now I'm going to explain about the concepts behind deep learning. Previous talk is on the basics of machine learning with less data. But here in deep learning with the complex data, we are going to develop the deep learning model. As I mentioned earlier, in deep learning, neural networks is the main component in deep learning model. So neural networks means it mimics like a human brain, how human brain works. So that's why in deep learning, the fundamental unit of a deep learning model is neurons. So this is the neuron is the basic unit of a neural network. See here in this slide, we see many neurons are connected together in different layers. The first one is the input layer, and the next middle layer is the hidden layer and output layer. So what is these layers? These layers are composed of metric equations, only equation. Each layer is some all is a combination of equations, but we can call it as a neurons. Okay. For instance, neural network topology. First layer is the input layer. So our features, data features are loaded into the input layer. So input layer function is to load and store raw input data. Whereas in the hidden layer is contained learned information from the log. Because as I mentioned earlier, we need to train the model. Once we train the model, then only the model will go for the prediction or any kind of inference it will give. So the training is taken place in the middle layer, whereas the learning process is training means learn the features of the data. First, the model has to learn the features of the data. From the learning, it will store everything and it has to understand the conclusion and it will predict the data. So the output layer is a get prediction from the network. So input layer loading the data, hidden layer for learning information, output layer for predictions. So this is a simple topology of a neural network. This neural network is the major component in deep learning AI approach. So here weights and bias, these are the mathematical components inside this neural network. Weights is a coefficient. As I mentioned, all these implementations are through mathematical equations. So in the mathematical equations, matrix are used. In the matrix, you have some coefficient. That coefficient we can call it as weights. So weights are the input signal to amplify or minimize the input signal. Bias, value added to ensure the nodes. Okay, then the transformation of combined inputs, weights and biases, and the transformed values is input to the next node. And we have to introduce a non-linear function to the neural network, because linear functions, because most of the data are non-linear. So we need to introduce the non-linear functions. So, and as I mentioned, all these mathematics use functions. Okay, so this is one of the function activation functions used in hidden layer functions. Hidden layer activation functions: rectified linear unit, tan h, sigmoid. These are the mathematical functions, activation functions used in the middle layer, which is a hidden layer. So output layer activation functions are sigmoid and softmax. If your problem is, I told you, all problems are classified into two. One is a classification divided into two groups: classification and regression. But here in deep learning handles classification. So we have two types of classification: binary and multi-class binary. So if you use if your problem or use cases has a binary classification, you have to use the sigmoid function. Whereas your classification is a multi-class classification, then use softmax. So it depends on your use cases, applications. So in order to choose a particular application, you need to identify which type of activation function you have to use it in the hidden layer, and which type of activation function you have to use it in the output layer. So that you have to develop your neural network model. And cost functions are loss functions. These functions are used to estimate the model learning performance. So once the model, we have to stop the model learning process. How do you understand whether the model is learn all the features of your data? So there is a function called cost functions. So if you minimize the cost function, actually it is an iteration method. Once you develop a model, you have to give input, load the data till it learns properly. So during the learning process, you need to model learns by minimizing the cost functions. When the learning process goes, if you get the minimized cost function, meaning that it is this set of parameters are used to represent the data. So it is a measure. Cost function is a measure how good a neural network did with respect to its given training sample and expected output. So because basically we are giving a training sample and we are expecting an output. So this cost function is a measurement how good your neural network performs. So minimum cost function, the less the reduce the training and everything, and then you will get the perfect model. So what are the classifications you are using here? For a classification function, cross entropy cost function, multi-class cross entropy, negative log likelihood. These are all the things used in classification cost function, used in classification type of loss functions. Whereas for the regression type loss functions, mean squared error loss, mean absolute error loss, these are all the functions. So using this cost functions, use this formulas, equations, so that these functions will help you how good your model, neural network model. Okay. So now training. What is mean by training? So this is your model. In the model, if first forward directions, you have to give the data. So it will go many iterations until it reaches the minimum cost functions. This is called uh, training process. So training of deep learning algorithms minimize the cost function. As I mentioned in my previous slide, so to minimize the cost functions, and then it is if it is in an acceptable range, then it is a good model. Okay, in this deep learning model, there is a, because basically it uses neural network. There are varieties of models. The common one is convolutional neural networks. So this is one of the neural network, deep learning neural network. We can call it as CNN. So the architecture of CNN, it has a input layer, and it has a feature extraction layer and classification layer. Input layer is only for loading the data. Because since it is CNN is a deep learning model, so feature extraction is automatic. So in feature extraction layer, you have a convolution layer, okay, and for the ReLU layer, for introducing the non-linearity, there is a pooling layer. The pooling layer downsize the samples, because when your data size is more, so you have more storage and more process. Fast. Processor. These are all the difficulties. Actually, we have some reasonable amount of processors, speed of processing unit, and as well as the graphical processor also, so that we need to minimize the data size. So that's why we need to downsize the samples. Okay, so later slide will explain what is a convolution process, and what is ReLU, and what is pooling process. Okay, convolutional CNN model handles cases in which data are images. So actually, in image means you have colors, 3 colors. So it's a 3-dimensional perceive image as a 3-dimensional object, width, height, and depth. So that the data for each image is very huge. Okay. So what we need to do, we need to apply filters to extract the important features. If you have, for example, you have an image. In the image, there are many pixels. So I want to identify a image, classification. For example, when your card, you access the card has to identify whether the person is so and so. So in that, we need to extract the. We are using the machine learning deep learning model. So we are using the neural network CNN. So in that case, if you have an image, image has a lot of features. So it is impossible to take all the features. So what we do, we use filters to extract the local features, and then from the features, we can give it as an input. In the layer for training your model. So in that case, feature extraction, we are using the convolution process. So convolution is a mathematical process. What we do, you have this is your image, and then from the image, what you do, you have to patch with the conversion operation by using a filter of to extract the local features. So this slide will explain to you. You have your image. Your image is a 5x5 image, and then you do a filter, which is the 3x3 filter for the convolutional operation. After when you do the cross product, so you will get the feature map. So in this feature map, you reduce you will take the important features from the image. So for example, first, this is the sliding. We are going for convolutional method. We operate these two, so that we product this filter as well as the main image, so that you will get 4. And then you move to for another slightly, you slide it over here, this filter, so you will get 4. So like that, you create a feature map. It is basically a convolution mathematical operation. So that after convolution, you will get the feature map. This feature map is important for your convolution process, because I told you in the layer, you have input layer, your image, and then you have a feature, middle layer. In the middle layer, you have automatic feature extraction, so using a convolution. And after that, we need to introduce the non-linearity. Why you use non-linearity? Because it is needed in the activation vectors, because it aims in a neural network to produce non-linear decision boundary via non-linear combination of weight and inputs. So you can build arbitrary shapes curves on a feature plane. So the third one is a pooling layer, downsize the samples. Otherwise, you have more features, so the processing and everything will be difficult. So we need to take the important features to train the model. So learn weights of filters in convolutional layers. So the pooling layer, so it is a max pool 2x2 filters with the stride, means movement. Two stride means first you have to take this one and move another slide, so that you reduce the dimensionality and spatial invariance. That is the aim of your pooling layer. Okay, all this, once you model your neural network, deep learning approach, the neural network model, then you can apply into some use cases. For example, various use cases I told you for industrial point of application. Uh, this is the feature learning process for industrial learning, for identify the damage in quality department. If any product is damaged, the defect can be identified using CNN classification method. So your image, the image can be convolution. Convolution means your filter, as I mentioned, you filter it, get the feature output, and then reloop for non-linearity and pooling to downsize, and finally your feature learning process is over. Then finally you can get the. So these are all the examples for CNN. So hopefully today session you understand what is artificial intelligence and what are the subsets of two different subsets of artificial intelligence, such as machine learning and deep learning. And finally, the concepts, what are the concepts behind deep learning and machine learning, and the use cases in our two types of artificial intelligence use cases. So with this, I will conclude my session. Thank you very much. Have a good day.
Thank you so much, Associate Prof. Dr. Sadiq, for very knowledgeable and informative speech. Your lecture for sure has found actually it's targeted. Actually, we have some questions come up on our Facebook and our YouTube. So I would ask those questions. So I would be really appreciated if you can reply the answer in a very short form, because we also faced with a lack of time for our webinar. Mr. Kashyap asked that I did my Polytechnics diploma in mechanical engineering, and am I eligible for this?
Pardon?
One of our audience's questions that I did my Polytechnic diploma in mechanical engineering. Am I eligible for this program? I
Yes,
think this is a
sure,
very
sure.
general question, but
It's applicable to all faculties,
yeah,
mechanical, civil. They should know the basics of mathematics, and they have to go for the Java programming and Python programming course. After that, once you understand the concept, you can develop your own model.
well, there's another question also, Prof, asking that what is the important type of AI? I think that my interpretation of this question is that what is the importance of the AI?
The importance AI is actually in future, all the process is going to be automated. Okay, we
Yeah.
have a lot of electronics, processors, and so many advanced developments in our electronics. So you say you are using your day-to-day life, your handphone. When you touch your handphone, your WhatsApp and Facebook, everything, AI integrated. Okay, your gadget you are using, every gadget you are using. So it is our part of life. Knowingly or unknowingly, you are using AI in your day-to-day life.
Okay, thank you so much. Okay, for our audiences, I would like to say that you can still ask your questions after you watch this series of webinars. Faculty of Engineering and Built Environment at Master University has a series of very useful webinars for all the engineering students and those who are very interested in these topics. And we are following up with your questions. We try to answer all the questions even after the webinars are finished. So do not hesitate to leave us your comments and your questions or any other inquiries that you have. And also, we already shared a link that I would like to ask you all to feel free to leave your comments for our improvement in our webinars. Altogether, Associate Professor Dr. Sadiq, I'm really, really thankful for your time and effort. That lecture was amazing. I would really love to ask you to be with us for another session in future for sure regarding the AI and all the technologies towards the IR 4.0. Thank you so much, Prof. I hope to see you again. And all the audiences, thank you so much. Have a great day ahead and bye.